Okay, this is called linear programming, and linear means straight line. That means that we are going to be graphing things that are a straight line. Well, that should be pretty easy. Let's just do a little bit of review. If I just said, can you graph y equals 2x plus 1? It's hard to believe how many kids are like, I don't remember how to do that. But do you remember that there's a slope in there? Do you remember that there's a y-intercept in there? Do you remember the y-intercept is 1, and so it'd go through that? Is that ringing a bell? It has a slope of 2, which means it goes up 2 and over 1. And there'd be another dot there, and it keeps doing that over and over again, so it's kind of like a fairly steep line. Does this make sense to you? Yeah. Good. Now what if I change it to greater than? It's possible you have never had to graph that before. Correct. If you've got it solved like this with y's on the left, then if it's a greater than sign, some of you don't know what that means, that's the greater than symbol. That one right there, the one that points, there's the pointy end on the right, that's the greater than. If it's greater than, then it's above that line you'd shade. Now let's talk about that. Why would the points above that line work? Well, I'm going to give you one. Would you agree that this dot, I'll make it blue, this dot right there is above that line? Okay, and then that spot is at 0, 3. That's what that spot is, and that spot seems to work. So if I want to put in 0 and 3, first of all, does it work? Is y greater than 0 plus 1? Is 3 greater than 0 plus 1? Is 3 greater than 1?
Yes.
Yeah, so it works. Let's take a point out here at like 5, 1. Well, guess what happens when you put that in? Does it seem like it should work or not work?
Work.
5, 1 should work? Well, let's find out. I'm going to put in a 5, put in a 1. Oh, it doesn't work. Why shouldn't it work?
Because 1 is not greater than right.
It's not shaded. There's 2 sides of the line. There's the shaded side and the not shaded side. Do you get 5, 1 is not on the shaded side of the line? It's not supposed to work. So this is 10 plus 1 is 11. Is 1 bigger than 11? No. So that's why it doesn't work. All right. Now, another important thing. Well, I want to do too many things at once. I'm just going to try to give you another one. Let's make this y is less than 3x plus 0. I don't need a perfect graph, but make me a graph of that. Figure out where to shade it. Above or below it. And then maybe just pick out a point and make sure that it's actually working. Like on the shaded side. Oh, pick a point and see if it works. All right, should have known the y-intercept, which is some spot along the y-axis, was going to be 0. And then the slope is 3, which means it rises 3 and it runs over 1. So this is very steep, and it goes like that. These are linear, which means a straight line. Now, I didn't keep my line perfectly straight there, but hopefully you can forgive me. That is my graph. Now, I got a shade on one side or the other. I made this one pretty almost like straight up and down, but there's still an above and a below side. That less than means we're supposed to shade below it, which is that way. That is what's under that graph. Okay, and now I'm going to pick a point that's over there. Like 6, 1 is definitely in the shaded region. It's on the shaded side of the graph. So if I put in a 6 and I put in a 1, it's supposed to be less than. Is 6 really less than 3 times 1 plus 0? No. So what did I do wrong? I did it wrong on purpose. I mean, I knew this was going to work, but it didn't work, so...
6 is the x.
6 is the x, not the y. You can't just put them in order from left to right. This is the x. I knew it was supposed to work, so I knew that there was something wrong there. Wasn't intentional at first, but then I knew how to fix it. So then I've got 1 is less than or equal to 18. That's definitely true. All right, so it worked. Pretty smart to check that, because do you get if you shade on the wrong side, the whole problem's toast? There's only going to be 4 hard problems on the test. They're almost all going to be this stuff, where you're graphing it. And if you have a problem on the test, this is not just going to be as easy as one thing. Watch. What if I had another line and it went like this, and it was shaded underneath it? What if I had another line and it went like this, and it was shaded above it? Do you get how all those shadings are going to get really confusing? And if you shade one of them in the wrong direction, it's all done. But where those overlap would be right in here. That place is called the feasible region, because points that are in there, like if I pick this spot, it looks to me to be like 2, 2. Points that are in there are the only points that work in all 3 equations. See what I mean? Feasible. Those are feasible. Those are possible. All right. Listen, this is really important, guys. So this shape that I got at the end is just the product of me shading 3 lines and seeing where they overlap. But listen, because this is important. Your answers to the big, tough questions at the end are pretty much always the corners. They're where those 2 lines intersect. Those spots where they intersect, like there and there and there. Those spots where the 2 lines cross. So let me give you an example of that. Y equals 2x plus 3 and y equals 6x minus 1. Will those lines cross? First of all, I can guarantee they're going to cross because of their slopes. Did you know that if they have different slopes, they will have to cross? If you didn't know that, now you know that. How about if I say it this way? What if their slopes were the same? Then they'd be, starts with a P. Parallel. And do you get parallel things never cross each other? They're like train tracks. So the only way that they won't cross is if their slopes are different. So these slopes are different, aren't they? So these 2 lines cross. And you've got to get good at finding where they cross. That is called solving a system of equations. This is like the ultimate in Algebra 2. Because number 1, you have to know an equation. Number 2, you have to be able to handle 2 equations and where they intersect. Now, could you find that by graphing? You can. But a lot of times, the graph will be really hard to read and you won't have a calculator. So I'm going to remind you how to solve this system of equations. I'll do the first one. I'm going to put it right underneath each other. Y equals 6x minus 1. Now pay attention, because you're going to be expected to do this in a second. You can watch me on this one, but just watch close. Now, if I draw a line like this, I want to see if anything will just naturally drop out. If I subtract this whole equation like this, will anything drop out? And the answer is yes. Would you agree that y and minus y will cancel each other out? And they will equal 0. And these 2, when I put them together, I don't want to call it subtracting. I want to call it 2x is going with negative 6x. That'd be negative 4x. And then this minus 1 makes positive 1. And the 3 get combined together, and that makes 4. If you can't solve that, you're in the wrong class. Solve that. Because I don't think you're in the wrong class. Solve that. It's not hard for me.
Did you just subtract everything?
Yes. Except I wouldn't have called it subtract. I would call it combining, because sometimes I added. You know what I mean? Like here, I was subtracting a negative, so therefore it's positive. You know what I mean? Right here. So you don't want to really just say subtract them. It's combining the top one and the bottom one. But I made the bottom one all negative. You can do that. I stuck an extra negative on all of them, and you can do that. Can't I do that with normal math? 4 plus 5 equals 9. And can I make them all negative? Yes, you can. -4 and -5 makes -9. You can do that. All right, so this is just solving equations. You gotta not doubt yourself on that. You're pretty good at solving equations. Subtract 4. -4 equals -4x. Divide both sides by -4. And x equals, what's -4 divided by -4? 1. So x equals 1. I solved it. No, I didn't. Because they don't have y. Very good. When you have two equations, the place that they cross is a point. Catherine, that goes in the phone jail. I know, it was irresistible. Oh, okay. My bad. Dang, that looked a lot like a phone. Sorry, I got burned a couple times recently. So I'm a little sensitive to kids using their phone class. All right, so back to x equals 1. X equals 1 is up, not a point. It's a number. Here's my two equations. If I know x is 1, but how am I supposed to figure out what y is? I told you x was 1. You can't tell me what y is then? Y is 5. If x equals 1, then you can stick it into either equation. And you can figure out, see, y equals 2 plus 3, y equals 5. Now that is a point, 1 comma 5. That is the solution to the system of equations. That's where the two lines cross. At 1 comma 5. And why do we care where the lines cross? Because look, a typical problem is going to go like this. They're going to have a line like this. They're going to have another line like that. And that makes up part of the feasible region. And wherever they cross, finding that spot will be critical. Because if, let's say, the third line is like this, here's our feasible region, you've got to be able to find spots like that. The corners, also known as the vertex of the feasible region. Okay, that's a lot of algebra. Let's see if you really got that. Here's another equation. Y equals 6x minus 4. And y equals 2x plus 7. Would you agree that these two lines will cross?
Yes.
Because their slopes aren't the same. So you can do it in more than one way. This way I'm showing you is pretty versatile. You draw a line across, and you see if anything would drop out. Do you get if I make this whole thing negative, something's going to drop out? The y and the minus y. They're going to be 0. Now I can just combine everything. I hate to say it, but I can't tell anymore. That was a minus 4, wasn't it?
Yeah.
Okay, minus 4 and minus 7 makes minus 11. Add 11 to both sides. Divide by 4. 11 fourths. Now, I on purpose just wanted to put up a problem quick, but the bad part about it is, if x is 11 fourths, we'd still have to figure out y. And we'd have to go stick the 11 fourths into either one of these equations, and it's not going to work real nice. Remember, I figured out x. X was 11 fourths. But now I'd have to put it in here, and I'm not going to make you do that, because on the test we would have used nice numbers, so you'd be able to find it. So this would be 66 fourths minus 4, which is going to be a real pain in the butt. It's not impossible, but... All right. So, if I give you an equation, do you feel like you could graph it?
Yeah.
Do it. Graph that. Y is less than x minus 4, and there's a twist. I'm not making a big deal about it, but there's something different about this one. Graph that. Okay. The slope on this thing is a 1. You can always put in a 1 if you don't have any other slope. It starts at -7, which is way down there, and that has a slope of +1. Well, that means it goes over 1 and up 1. I could put 1 over 1 if you wanted to see the rise and the run. Over 1, up 1, over 1, up 1, and basically makes it like a 45-degree angle line like that. There we go. Now, should it be a dotted line? Yes, it should. Did anybody remember that deal where if this is just a less than, then the line itself should be dotted? Anybody know that? Nice. But a lot of people didn't. And that's going to happen on your test.
Wait, why is it dotted?
Because there's got to be a difference between less than and equal to, right? The things that are on the line don't work on this kind. All right. Now, which way should I shade? It says less than.
Right.
On the right side of the...
Don't think right and left. That will mess you up.
On the bottom side.
On the bottom side. There's above and below this line, and that's below this line. Less than means below, and it makes sense. The temperature was less than 0 degrees. Well, that's below 0. Less than and below makes sense. All right. Now, could you write an equation like that? Let me give you an example of one. These get really tricky, and we're going to spend a whole day on writing equations. I'm just giving you your first one. John makes $12 an hour when he goes and works with Mr. Johnson. But he's like, man, that's not very good pay. And Mr. Johnson says, well, how about if I give you $50 every day that you come over, and then after that, it's going to be $12 an hour. And you were like, dang, that's a pretty good deal. I guess I'm going to take that deal, because then if I only work for an hour, I'm going to get $50 plus the $12. Can you write an equation for that? You get $12 per hour, but $50 just to start with. Doesn't depend on the hours. The $50 is just once. Hint, I always start with y equals. And then it's $12 an hour. That's 12 times h, but in this case, I'm going to use x and y. Always use x and y. If the problem doesn't use x and y, change it to x and y, because otherwise you can't graph it. And then how about the 50? That's plus 50. Now, how is this different than the ones we did a second ago? Those were like less than or greater than. This one's equal to. So if I wanted to make this into a less than problem, they would use words that make you think that how much you make, this is how much you make, will be less than that. Why? Because Mr. Johnson or whoever you're working for is kind of cheap on the hours, and he's like rounds the not nice way, and you work 12.2 hours. He's not going to give you that. He's just going to give you for 12 hours. So he's kind of a cheap jerk. So you're going to get less than this. But you'll always get your $50. All right, see how I made it less than? And this was the hours. All right, for today, the main goal is to get you to be able to graph things like this, graph other things on the same graph, and if I had to just rough estimate this, I'd say that's going to be where 50 is. Slope's going to be 12, so I'm going to make it like fairly steep slope, and it'll be like that. Probably should be steeper than that. Yeah, let me fix that. And then if it's less than, see like this, then I'm going to shade under it. Mostly for today, we're going to see, can you graph that? Can you graph another one that's on the same axis? And then can you figure out where they cross? The thing I'm most worried about isn't the graphing. It's the where they cross part. So I'm going to give you one more like that. You ready? 2x plus 4y is equal to 12. Now, when you're finding where two lines cross, we don't mess with less thans. We just change them to equal tos to see where they cross. Now, this one isn't solved for y, but that method I showed you before is still going to work. 2x minus 4y is equal to negative 20. Now, if you solved this thing, you'd have to think, would the slope, which is the thing on the x, end up being different on the one than the other? Yeah, it would, because one of them is negative. Now, this one's a little too weird. I apologize, I just realized. No, wait, this one will work. This one will work. Okay, sorry. Okay, now how do we see where they cross? I said draw a line across. And then did I say you always had to make the bottom negative? No, I didn't. I said, look and see if anything would cancel out. You see how the 4y and the negative 4y will cancel out? Then I can just leave them the way they are and combine them. Those combine, you can solve. Once you get the x, figure out the y. Then compare with the kid next to you. I'm going to pause and figure this one out. All right, these two will cancel out, so then I can just combine them, meaning I don't go through and make everything negative. If I did, then different things would cancel. So 2x and 2x makes 4x. These cancel and make 0. You can put plus 0 if you want, or you can just make it be gone. And then this is negative 8. So what's x have to equal? Negative 2. Is that the final solution? No, it's one of the parts of the answer. Okay, so now I got x is negative 2. Negative 2 comma what? Well, figure out the y. Von Smith, can you tell me where to put this negative 2?
You can put it either
Yep.
x, but I'm choosing to do the blue section.
I agree. I'm going to put the negative 2 there.
So you get negative 4. May I fix all the wrong?
Please.
Yes or no? Please no or please?
Oh, I thought you said, may I solve the problem? And the answer would be yes, you certainly may solve the problem. We're this far. Now what?
Okay, so then you add 4 to the other side to get 4y equals 16.
I'm going
Divide
up,
by
which is
4
not
on each
normal,
side,
but
you
it
get
works. Equals 4 and 16. Now what?
Divide by 4 on each side, you get y equals 4.
There you go. So I figured out the x was negative 2 and the y was 4. Raise your hand if you had the same thing. Awesome. You found the corner of what would be called the feasible region. Remember, in the context of this, we would have graphed both of these. We would have figured out that they cross at negative 2 comma 4, something like that. And maybe the feasible region was, typically we have 3 lines that intersect and they make like a triangle. That's pretty typical. Question?
So you do not have to make all the numbers on the red equation negative?
Okay, on this one, I didn't need to make anything negative because these two automatically would cancel out without me doing anything. If I had, it would have been okay. Look, if I make this negative and this positive and this negative makes it positive, it would have actually still worked. These two would have canceled, and this would have been 8y equals 32. And 8 times 4 is 32. We would have solved for y first. So it would have actually worked if you made everything negative. Okay. So I need to get you into the homework for today. So everybody open up the worksheet for homework for today. And we are doing the even problems. As in 2, 4, 6, 8. Go to problem 2. Alex, would you read me problem 2?
X is less than or no, x is greater than or equal to 3.
Okay.
X is less than or equal to 7.
Okay.
Y is less than or equal to 10. And y is greater than or equal to negative x plus 8.
All right. Now, as we get into graphing this, you're going to have to remember a few things like how do you graph something that's just x equals? And I'll show you.
It's just a straight.
Would you agree that this is the spot where x is 3? Now you only have two choices. Your line either goes like this, like the red line, or the line goes like that through that spot. It's either a vertical line or a horizontal line. Which do you feel like is right, the red one or the blue one? The red one. Because think about it. It's x is 3, meaning that's a spot where x is 3. That's a spot where x is 3. That still has x is 3. See, all of these spots have x is 3, so it's that line. So that is a vertical line going through 3. Now, I always said you should shade it based on above or below, but this is the only kind where you can't do that. You can't shade above or below a line that goes straight up and down like this. So then you got to think left or right. I want bigger than or equal to 3. Do you agree the bigger than numbers are over there?
Yeah.
So I'm going to shade to the right. There, I've graphed one of my lines. Is there going to be more? Yeah, there's a lot more. You'll catch on. X is greater than or, less than or equal to 7. Well, let's say, here's 7. I'm going to draw a red line through 7. 3, 4, 5, 6, 7. And it wants to be less than that, which means I shade this way. Pro tip. Don't shade across the whole graph. Just shade a little ways past the line. Otherwise, you're going to have so much shading, you're going to get totally lost. Do you get how I just shaded a little bit on one side of the line to show me which way to shade? Okay, now I'm going to do y is 10. Well, that's a line that goes through like up here at 10. And it's less than or equal to 10. So then I go under it. I can see a rectangle's kind of forming up here. But wait, this last one, it has a negative slope. How do you do negative slopes again? Well, they just don't go up from left to right. They go down from left to right. And this has a y-intercept of 8. And it has a -1 slope. So I go like through here. Goes down 1 over 1, down 1 over 1. It's kind of like that. Do you get, I'm not exactly sure where it hits here, but that's going to be a big deal. That's the point. Can you find where those two lines intersect? Where this line intersected with this line? Well, it says x is 3. Can I just put in x is 3 here and solve it? Yeah, you pretty much can. To see where those two cross. Do you get, I just graphed two lines that crossed?
Mr. Server.
Do you get that I just graphed two lines that crossed? Okay, so I was just explaining that this line and this line are the two lines that just crossed. Yes, James.
But don't other lines cross as well?
Oh, sure.
Why is that like the special line?
Well, that's one of the special points. There could be, these two are going to be pretty easy to see, like where that is. Do you agree, Ms. James, that these are both like very easy to find points because they're right on the other lines? I mean, this one says x is 3, and this one says y is 10, so that point will be easy to find. And this point will be easy to find too, because this says x is like, what is it, 7? Yeah, x is 7 for this line. So these points will be easy to find. It's the ones where you have a diagonal line and a straight line that are harder. All right, and then which way was I shading on this? Is greater than. So greater means above. So I'm going to shade just above that diagonally line. Now, do I expect you to be a master of the, gentlemen, you're talking the whole hour. Do I expect you to be a master of this after one day of the new unit? No, we got a whole unit on this. Okay, but if you don't know how to graph by the end of today, you should be coming up and asking for help because it's just going to get obviously more complicated tomorrow. All right, now it's even, and there are some at the end where it's going to be hard to write the equations. Make sure you look at the key. There's a key posted for a reason. But you only have to do the evens, and then it gives you plenty of time to work so you can come up and ask questions. Now it's on you. That's all I got for you for today.